tomorrow will be better. Solve x squared plus 6x minus 1 equals 0. Follow me, dear friends. Solution. Clearly, we have a quadratic equation on the board in which a, which is usually the coefficient of the square value, is equal to 1. B, which is the coefficient of the x value, is equal to 6. And C, which is usually the constant term, which is just -1. There are several methods of solving quadratic equations. Most common ones are the factorization method, completing the square, formula method. There's also the graphical method which can be used to solve quadratic equations. Now, one very commonly used one is the factorization method because personally I like it. It's quite easy and practical. But the question now is, what if this equation on the board is not factorizable? Because in case you didn't know it, not all quadratic equations can be factorized, alright? So what do we do if we have an equation which cannot be factorized? The first question should even be, how do we know, alright? How do we know that this equation here cannot be factorized? Because if you don't know how to determine, you're going to waste a lot of time trying to find factors, trying to find factors of AC, which when added are going to sum up to B and all of that. It will be a waste of time. The first step is to determine whether or not this equation here can be factorized. How do we do it, guys? Follow me. To determine whether our quadratic expression or equation can be factorized, we use the discriminant function. Let's represent it by D. It's given by B squared minus 4AC. Once we use this determinant, we can know whether we can factorize our quadratic equation or not. How? If the result of this discriminant is either a negative value or it's a value which is not a perfect square, then there's no need wasting time. You can never factorize this equation when we talk about real numbers. Okay? In the domain of real numbers, it will be impossible. So let's try it for this particular case and test if it can be factorized or not. Like I said, what is B? B is 6. 6 all squared minus 4 times A, which is 1, and then times C, which is -1. So what does this give us? This is going to give me 36. Now there's a negative here. We could put it like this to minimize errors. There's a negative here. So let me first write like this. 4 times 1 is 4. Now times -1 is -4. Okay, be very careful with this. Here now we're going to have that 36 minus -4, which is 36 plus 4, and which gives us 40. Now notice something. 40 is not a perfect square because the square root of 40 is going to give us some decimal number, okay? So 40, though it's a positive number, but it's not a perfect square. Therefore, this equation on the board can never be factorized in the domain of real numbers. So dear friends, what do we do? The best method here right now is to use the formula method, okay? So let us recall the quadratic formula. Since it's 1 in x, we're going to say x1 or 2 is going to be equal to -b plus or minus the square root of b squared minus 4ac, all of this all over 2a. There are two things here. The first thing is to master your quadratic formula. The second thing is to know each of these parameters in the formula. You have to know what A stands for, you have to know what B stands for, and what C stands for. But in order to achieve this, you have to make sure that your quadratic equation is in the standard form of quadratic equations, because sometimes you could have equations which have this constant term to the right side. So you have to reorganize your equation to be a standard quadratic equation, okay? So having written this down, all you have to do now is substitute each parameter in the equation. Okay, now what do we have? Why do we have x1 or 2 here? This is simply because all quadratic equations must have two solutions, okay? So x1 or 2 is going to be, in accordance to this equation, will be -b, which is 6b, which is 6, so -6. Now plus or minus the square root of this piece. Here, let me go to the side of the board. So x1 or 2 will be negative 6 plus or minus the square root of b squared 6 all squared minus 4 times a 1 and times c negative 1. Be very careful. All of this divided by 2 times 1, 2a, alright? At this point, you just have to be very careful in the simplification process, taking into account the various signs, okay? This boils down to x1 or 2 equal to, here we have negative 6 plus or minus square root of, this is 36 because 6 squared gives us 36. Now in here we have 4 times 1 and times minus 1, which gives us a negative 4. So inside this bracket we have a negative 4. Be careful, there's another negative out here, alright? And at the end of the day, this negative 1 times negative 4 will give us positive 4. And then all of this divided by 2, because 2 times 1 is 2, alright? So x1 or 2 is going to be equal to, now I'm going to simplify this expression here. This will boil down to the square root of 40, so, and then all over 2. Now, here comes the application of the two values of x1 and x2, and all is going to be played at this level here, because this shows us that there will be one value obtained from using plus and the second value be obtained from using negative, alright? So x1 here is going to be negative 6 plus square root of 40 divided by 2, and then x2 is going to be equal to negative 6, this time around minus, okay? That is where the use of or the application of the plus and minus come in, all divided by 2. At this point, if you are not very sure about the further simplification, you could leave it like this, okay? But if you want to further simplify it, you can now use your calculator and then get the square root of this and also apply it down here, and then you're going to have some final answers here. And then that's going to be your answer, because tomorrow will certainly be better.